Alright, so we've looked at adding and subtracting polynomials. And so the next thing that we're going to get into is multiplication. Now, before we can talk about multiplication, we do want to review basic rules for exponents. So this will be section E3, and this will be divided into two sections. Part 1, we're going to talk about, or what we need to know in order for part 1, is how to add, subtract, and multiply integers. We also need to understand how to evaluate exponents. So basically, numbers raised to other numbers. Upon completing this presentation, you will be able to apply the product rule, quotient rule, and power rule to simplify expressions involving numbers and variables raised to exponents. So let's talk about what these rules are. The first one that we want to look at is the power rule. And the power rule says that if the bases are the same, then if we multiply, what we're going to do is add the exponents. So let's see an example of this. If we have 2 to the 4th times 2 cubed, well, 2 to the 4th, that is a total of 4 2's, and 2 cubed is 3 2's. So how many do we have total here? We have a total of 7. So how do we get that? We get that by adding the 4 plus 3. There is your product rule. The next one we have is the quotient rule. And so if we look at the quotient rule, let's say that we have 2 to the 7th over 2 cubed. Well, 2 to the 7th, that is 7 2's. Two cubed is 3 2's. And then now what can we do? Well, we can cancel out a total of 3. What does that leave me with? That leaves me with 2 to the 4th. How do we get that? From 7 and 3, we are going to subtract. And the final rule that we're going to look at in this presentation is the power rule. And the power rule deals with raising exponents to other exponents. So if we look at this one, let's say we look at 3 squared, and I want to raise that to the 4th power. Well, what that's equal to is 3 squared times 3 squared times 3 squared times 3 squared. There's 4 of them. And each one of these is a 3 times 3. So how many do we have? Well, we have a total of 8 now. So where did that 8 come from? That 8 came from multiplying 2 times 4. So those are your basic rules that we're going to be working with. So note, when working with exponents, think about things that we have done in the past. We're going to be extending the concepts of distribute and combine like terms. In this section, what we can think about is think going down an operation. So for instance, when we talked adding and subtracting, we did nothing with the exponents. We kept them the same. When we multiply, we want to go down an operation to addition. And similarly, when we talk about dividing, we want to go down an operation to subtracting. When we raise an exponent to another, we go down an operation to multiply. So what do I mean by going down an operation? Well, think your order of operations. Please excuse my dear Aunt Sally. Exponents, we go down to multiply. Multiply, we go down to add. There's nothing below addition. We'll get to when we talk about going from exponents to dividing later. But for now, division, if we go down to subtraction. And again, subtraction, there is nothing below subtraction. So now let's go ahead and look at some examples of this. So for example A, we have 2 squared times 2 cubed. And so we can add our exponents. Remember, multiply, we want to back up an operation to addition. And we end up with 2 to the 5th. For example B, we have y times y to the 5th. Well, if you have y to the 5th and you want to multiply by one more y, what are you going to end up with? This should be y to the 6th. Well, how do we factor in this whole idea of adding exponents into this? Well, remember that we saw in the first section of this module that if there is no number in the exponent, it is implied to be a 1. For the next example, example C, we have y cubed, y squared, and y to the 5th. So we have 3 y's, 2 y's, and 5 y's all being multiplied together. If we add our exponents, we have y to the 10th. And there is your product rule. Okay, let's look at our quotient rule. For example D, if you have 8 2's on top and 4 2's on bottom, you can cancel out 4 of them. So how many are left? Well, you should be left with 2 to the 4th, or 8 minus 4. For example E, if you have 13 x's on top and 3 on bottom, we can cancel out 3 of them. And how many are left? We should be left with 10, or 13 minus 3. For F, if you have y to the 15th divided by y, basically what we're saying is we want to take one y away, and what will we be left with? We'll be left with y to the 14th, or 15 minus 1. And finally, we have our power rule. So for this one, remember what did we do when we had parentheses before? Parentheses meant multiply. Same thing when we talk about exponents raised to exponents. So what we have here is I want to multiply 3 times 5, giving me 2 to the 15th. And for H, same thing. When we have an exponent raised to an exponent, think of multiplying them together. We get x to the 24th. Now, if you do get stuck, remember that you can do exactly what I did when I explained these rules, which is write it out in expanded form and either add them together, count them up, or cancel them out. Either way, you should still come up with these answers. So, basic rules of exponents. When will we see this again? We will revisit these rules of exponents throughout this module as we expand into multiplying and dividing more complex polynomials. We will also use these basic rules when working with rational and radical expressions. Take a moment and try the following problems on your own and bring your solutions to class along with any questions that you may have. Go ahead and take a minute to pause the presentation here so that you can go ahead and work on these problems before continuing on to the next slide.